From screen time to sense making. What is missing? So can children really learn by sitting in front of a screen? Or is something lost in translation? Let's find out today. So digital tools should complement conversations, hands-on activities, and play. This is what we're going to talk about today. So let's start with, how do children learn? So we've had some incredible psychologists, some authors over time. So Vygotsky from the early 1900s, Piaget from the mid-1950s and 60s, and they talk about how important it is that children to learn have to be playing with each other and having social conversations. That is absolutely critical. And then today, with neuroscience, we're able to look in at what actually is happening. And it's really important that kids are perceiving things, and then they are engaging actively with different objects, and then moving to visual representations, and then that helps actually create systems in their brain so that they can actually remember really important ideas. So as an example, like if you're in kindergarten, we want kids to take some blocks and stack them. And what they're doing as they're playing with the blocks is they are feeling the texture. They're counting 1, 2, 3, 4, 5. They're looking at color. They're checking the balance as it's maybe tipping over one way or another. And that is what neuroscience and Piaget and Vygotsky have talked about in the past. That's so critical to get those neural pathways for us to be able to think symbolically and have the images and all the perceptions together. That's what learning is really about. There's also then, well, okay, fine. What about screen time? Is there any positives? Absolutely, there's some positives. So once you've already learned something, it's great for them to practice on computers. They also have adaptive feedback, which is really incredible. So you can get really quick feedback right away, whether you're right or wrong. And they also, when you're focused on really abstract concepts in mathematics, it gives some great visuals. So that's really incredible as well. But there are some really big costs if you're putting your kids in front of that screen way too much. And we have a lot of evidence where over 50% of US students are in front of screens a lot of the time. So be thinking about this now. 3 things that they're missing. Embodied cognition. So that is the idea of that you have to physically be working with something. And as we talked about from the neuroscience aspect, that's really critical. 2, dialogues and conversation are absolutely critical. That allows you, like when you're looking at somebody, you can see from their face, their reactions, like you're on the right track, you're not, they're unsure. And so those conversations are absolutely critical. And 3, emotions and motivation. So with a teacher can come in and give you a nod going, you got that right, keep going. Or, let's pause and think about this. So with the teacher and the students in the class, you can do so much more, and that's what really builds true learning. Okay, so there are, to kind of recap, let's think about, there are 5 developmental costs. The first one is conceptual coherence. When we're actually having social conversations, working with the teacher and other kids, that's building a really important conceptual understanding of the mathematics, not just a procedural understanding that you're getting from screen time. So there's that difference. The next one is metacognition. Your ability to think about what you're thinking about when the teachers and your classmates are challenging you or questioning or even just giving some type of gesture or some look, you're able to start rethinking about your own thinking that you don't get that on screen time. The third one is executive function. And so what we're thinking about, and part of it is attention. So with screen time, you are attending to the things on the screen, which is good. And a lot of times though, it's a lot of games and animations, which is getting away from the content, but it is keeping kids attentive, but it's not deeply getting them engaged. And so when you're with classmates and the teacher, you can be challenged in 3 or 4 different ways. Again, socially, building something with your hands, reacting to symbolic equations, all of that is more important to really build that executive functioning. The fourth one, you're lost at curiosity and creativity. So a lot of times when you're together and having conversations, kids ask, like, I'm not sure about this. What do you think? And all of a sudden, you can get much more curiosity while you're live with teachers and other kids. And the fifth one is that human connection. We as humans absolutely need to be around others. That helps going back to that motivation and just encouragement and getting us to actually understand the mathematics. Another piece with the human connection is perspective, because you might be thinking one way and somebody brings up a completely different point. And now all of a sudden what you thought was black and white, there's more gray. And that's really important to make sure, again, that our brains are expanding and we're thinking much more deeply. So that gets back to the screens versus sense making. We really want kids to be sense makers. And remember, we learn by doing, by feeling, by talking, and by imagining together. So in our link, we have an incredible math pack for 3-year-olds to 8-year-olds. These are the best manipulatives that you can use for really learning mathematics. So we'll have that link for you. We have a book on fluency to help you out. We have a lot of materials on the website. And if you also, we do have a lot of online games. Again, for practice, we have the math facts with sports for both addition, subtraction, multiplication, division. And those are wonderful ways from second graders on to really practice facts. If you want to learn more, please check out our Substack or go to our website. We have great resources, and we'll even come out to your school and provide amazing profession development with your teachers and in classrooms. So if you like this DMT Insight, check out our website, mathsuccess.io, and please like us and follow us.